So we've talked about the different types of energies, and now we're going to talk about the different resources that Earth supplies us with that we use for energy. So this entire PowerPoint is about different things like coal, fossil fuels, solar energy that we use to generate our electricity or to run our cars, etc., etc. So first thing we need to figure out is what we need to survive. There's four main things that every living thing needs to survive. All right, let's think about it. First, we need air, we need water, we need food, and we have shelter. We all know that we cannot survive for an extended period of time without any of those four things. We could break down food and shelter into more detailed categories. Specifically, we're going to focus though on our shelter, building materials, and energy. Energy that gives us electricity, building materials, obviously the concrete, the wall, the plaster for the walls that allow us to actually have a building. Those can be categorized more into metals and woods, and we can continue to do this into different types of wood, different types of metals. This is just an example. Each of these things, whether it be air, water, food, shelter, the building materials, the energy, the metals, the wood, these are all considered natural resource. And the definition of natural resource is any resource, naturally, that comes from the earth that we use as a energy source or as a resource. It could be water, it could be wind, it could be the sunlight, it could be lettuce, it could be dirt, it could be a tree, it could be a diamond, it could be wood, it could be anything. Anything that we use from the earth that we just have sitting here is considered a natural resource. There's various categories. Three main categories: air, water, and land. And within those, we're going to divide them again later on. First of all, air is important to us. It contains these 6 gases: oxygen, nitrogen, carbon dioxide, methane, ozone, and water vapor. Of course, oxygen we need in order to survive. We are inhaling it every single second in order to survive. Nitrogen is actually the most abundant gas in the atmosphere. We don't actually need it, but we do need it for the support of the rest of our ecosystem. We give off carbon dioxide, which of course plants inhale to give us oxygen. Methane, ozone, and water vapor, those are all considered greenhouse gases along with carbon dioxide that help keep heat inside of the planet so it is not negative 35 degrees below zero every single day. So air is important not only because it's oxygen, but it gives us other gases that other organisms need, like carbon dioxide that plants need, so they can give us oxygen. And again, nitrogen, methane, ozone, and water vapor, those all help keep air, moisture, and heat inside of our atmosphere. Water, there's 3 main things that water does. The basics: it regulates climate, okay? We've all experienced going at the beach and you feel that it's hotter, a little bit more inland because the shore, the water at the ocean actually helps cool down that area. Readily dissolves compounds, so that is like it helps dissolve salts, helps in the the rock cycle. And when it's purified, it can obviously be used for drinking, recreational purposes. We all like that. You can go on a cruise, you can go tubing, you can go jet skiing. So it's important for life's necessities, but also just for fun things that we like to do. And lastly, land resources. And land resources, we categorize those again into 3 main groups: soil for crops and growing food, bedrock, again, for some sort of construction, and mineral ores and gems. Those are like diamonds, jewels, etc., etc. Copper is considered an ore. And all of those resources can be divided into different energy resources. Any energy resource, is a natural resource that we use specifically for energy. So it's a natural resource that we use specifically to gain energy, to power something, to power your car, to power your house's electricity, to power the electricity being generated at a power plant. There's probably a few that we know, that we all already know. We have traditional resources: coal, natural gas, petroleum. We've talked about those before. There's a picture of coal. Uranium is nuclear, so that chunk of uranium is going to be found and used at a nuclear power plant, which we've talked about earlier. And water, ocean water, stream water, any sort of water that's part of the water cycle. Then we have alternative resources as well, which are becoming more and more popular. You've probably heard about them in the news. With a lot of new cars, we talk about them, or there's turbines. So wind, here's some wind turbines. Solar energy, we've all seen solar panels. There's even small solar panels on old calculators and the calculators that we use The blue one's geothermal energy, so that's heat from the earth. Biomass is new, but many of you will probably already know what it is without knowing that you know what it is. And hydrogen, like a hydrogen fuel cell. So each of these 10 items are specific natural resources that we use for energy, so we call them not only a natural resource, but an energy resource. And we're going to go first through the traditional and then through the alternative resources and determine which type of energy they give us. Does it give us chemical? Does it give us gravitational, nuclear? What is it? Again, this is review our 9 main types of energy. We're going to go through and identify which types of energy each energy resource gives us. So if we start with coal, coal is used for the bonds within the actual item. So that type of energy is going to be chemical. Another traditional resource, natural gas. Natural gas is another type of fuel or food for the item that it powers, so that too will be chemical. Another traditional resource, petroleum. Similar to coal and natural gas, it is again a fuel that we use for the stored bonds inside of the actual molecule, so it will be, surprise, chemical. All right, all 3 of these main traditional resources, energy resources, give us chemical energy. The last of the traditional, we have nuclear. That one again is used for the protons and neutrons attraction inside the nucleus, so that is going to be nuclear energy. No shocker there. We have water. Water behind a dam is going to give us gravitational energy because the water above the dam up here is at a higher height off the ground, off the surface of the earth as opposed to down here. Water will also give us motion energy or mechanical energy because it is continually moving. There are power plants specifically on the shoreline that use wave motion instead of just like a big reservoir. If we do the alternative energies, we can break them down again to the different type of energies. Some are going to be repeated, some are not. So we have wind. Wind is moving air, so that one will be giving us mechanical or motion. Whichever you prefer is fine. Mechanical is the best because, again, the turbine is high, so it does have a height off the ground, and it's moving. Solar will give us radiant energy, again, electromagnetic waves or radiant. Geothermal, it's in the name, okay, heat from the earth, so it's going to be thermal. And our last one is biomass. This is like a fuel. Again, this is actual plant material that is compacted together, so this is going to be chemical energy. Again, coal, oil, natural gas, those are all chemical. Nuclear is nuclear. We have water, gravitational, mechanical. Wind, you can change that to motion or mechanical if you wish. Solar is radiant. We have geothermal, thermal, biomass, chemical. Now, in addition to what type of energy they supply us with, whether it be chemical, radiant, mechanical, motion, whatever, natural resources are categorized based on how fast they are replaced. And we have 2 main categories. We have renewable energies, which are resources that are replaced quickly. Like it could be replaced in a second. As soon as it's used, it's replaced. As soon as it's used, it's replaced. Or there's a current continual supply of that energy. Short time for it to be replaced. And the opposite, we have non-renewable. So this is going to be, as we guess, a resource that's replaced at a very long time from when it's used. Long as in millions of years, hundreds to millions of years, most likely millions of years. Non-renewable, not renewed fast, renewable, renewed very quickly. So we're going to go through them quickly here. If we have wood or trees, those are going to be renewable. You can easily throw some seeds down into the ground, it will eventually be replaced. Yes, those trees will not grow to the same exact height in a quick period of time, but there is a ton of trees on this planet, so it is considered renewable. You can easily replace it. Diamond. Diamonds, what do we think it is? Non-renewable. We know this. Diamonds take millions of years to form. That's one of the reasons why they are so expensive. Okay. Dirt, soil. That is continually being replenished and recycled through the rock cycle, water cycle, so that is going to be renewable. If we have any sort of minerals, aluminum or any other metals, those are going to be non-renewable. Once it's used, it's gone. Water, it replaces itself in the water cycle, so it is renewable. And our last example here, copper, Again, very similar to our aluminum chunk before, which is non-renewable. You use it, it's done. You misshape it, it's done. So if we look at our sources of energy, coal, natural gas, petroleum, those four are all non-renewable. It takes millions of years. We've talked about this before. It's made through fossils. Okay, that's why they're called fossil fuels. Nuclear, once it's used, it cannot be used again. And all of the alternative energies, water, wind, solar, geothermal, and biomass, those are all renewable. They have a continual supply or a supply that will not be ending anytime soon. The top four are all interesting enough. Those are all our our traditional energy resources are always usually non-renewable, and all alternative energy resources are now renewable. Interesting tidbit there. Fossil fuels, huge discussion right now in the news and a hot topic in science that fossil fuels are a huge portion of the energy consumption in the world. This pie chart looks only at the U.S. We have petroleum as the yellow slice, coal as the brown slice, natural gas as the sky blue slice. Those are our three fossil fuels, and they make up the majority of our energy pie. Okay, they make up 86% of the U.S.'s energy resources. So the U.S. and other countries currently are trying to lessen these three slices and make these three much bigger because it is, again, healthier for the planet. It's more renewable. It's easier once they're in place to continue them from running. We are going to do this demonstration in class, so I don't want you to get the whole thing. But how long a fossil fuel lasts depends on whether or not the generation previously leaves something for you there, because it is non-renewable. All right, coal, oil, and natural gas are our last few things here, and we have talked about them before, so I'm just going to super quickly go through it. Again, we have these organisms alive 300 millions of years ago. They end up dying, they have to decay, they break down, and they don't do so in the air. They fall to the ground, they eventually get pushed down because more dirt comes on top of them, and water, more pressure, more time, higher temperatures. Over time, we end up getting a layer of coal forming. This happens in ancient swamps, so where the coal is found now, like West Virginia, Tennessee, things like that, millions of years ago, in ancient times, those were swamps. It's not like I have a swamp in my backyard right now and I can go dig up some coal. Not necessarily at all. It's ancient swamps from the dinosaur times. There are three main types of coal that you need to know about. Very straightforward. Coal is based on the amount of carbon that is in it, and these three, lignite, bituminous, and anthracite, go from lowest carbon to highest carbon. So lignite has the lowest amount of carbon here. It is the least shiny. Because it has the least amount of carbon, it has the lowest amount of energy. Less than 40% of it is carbon. Bituminous is in the middle here. It's about 45 to 86% carbon, so it has more energy, not the most. And anthracite, our shiniest coal, has the largest energy content, the largest carbon content, anywhere up to 97–98%. They are relative to how much pressure and how deep they are found. Anthracite is the deepest coal. It took the longest amount of time to make, and it had the highest amount of pressure to form, whereas lignite had the least, it's closest to the surface, and it's the youngest coal, if you will. Oil and natural gas. Again, this is a review slide. We had this exact same slide last chapter, but oil and natural gas are going to form the same way that coal does, except instead of ancient swamps, it's going to be from an ancient shallow ocean. So it's more marine organisms, again, that die. They end up decomposing. Their body parts, their bones, their skin, their scales, whatever you want to call it, break down over millions of years, becomes gas and oil. This takes millions and millions of years. That is the key. And I believe that is our last slide. I feel like we went through this pretty quickly, but yes, it is our last slide. So that is it for our Earth's energy resources. We will move forward, talk about the different power plants in a little bit more in depth, and that's all. Talk to you guys later.